Now, coming to the preparations of alcohols. First one is from alkanes. See, alkanes having a 3-degree hydrogen. So this is 3-degree hydrogen, 3-degree carbon to which a hydrogen atom is attached. With the KMnO4, you can take alkaline KMnO4. On oxidation with alkaline KMnO4, we get this. Okay. So only those with a tertiary carbon atom can actually give this reaction. Okay. Now from alkenes. See, we have 3 preparation methods for the alcohols from alkenes. The first one is acid catalyzed hydration. Okay. So in this case, we get alcohol. The interesting part is this is according to Markovnikov. Rearrangement is possible because here the intermediate is carbocation. You can check the mechanism in our alkenes chapter. And as far as the stereochemistry is concerned, nothing to say about that. Markovnikov and the rearrangement. I mean, the regiochemistry is Markovnikov addition. Okay. Now, the second one, oxymercuration, demercuration. With the mercuric acetate, water. Oxymercuration using that. Then the demercuration using sodium borohydride in the presence of alcohol. We get this product. Coming to this, the regiochemistry is Markovnikov addition with a no rearrangement. Okay. No rearrangement. And then coming to the stereochemistry, it is anti-addition. Hope you remember. Now coming to the third one, that is hydroboration oxidation. With BH3, THF, H2O2, OH minus. Yes. Now this is according to anti-Markovnikov. Kharash, anti-Markovnikov addition. Next, no, not Kharash. Kharash is when we use HBr in the presence of peroxide. Of course, that also goes by anti-Markovnikov. Now, of course, no rearrangement. Then, coming to stereochemistry, it is syn addition. We don't have any rearrangement. This is about the preparation of alcohols from alkenes. In alkenes, it is the property, but now it is the preparation method. Even this also. See, from alkyl halides, see, when alkyl halides are treated with aqueous KOH, SN2, a strong nucleophile, you get ROH. See, here you can also use the moist silver oxide, isn't it? Even this also gives alcohol. Okay. Now it is a very important one from the Grignard reagents. See, Grignard reagents are prepared by treating alkyl halide with magnesium metal in the presence of dry ether. Right. So, alkyl magnesium halides are Grignard reagents. Okay. preparation of alcohols from Grignard reagents. See the general reaction. I've taken a carbonyl compound when treated with a Grignard reagent. Look at this. You know, magnesium is more electropositive than carbon. So gets a positive charge and the carbon gets the negative charge. Even in this case also, oxygen being more electronegative gets a negative charge and carbon gets a positive charge. Okay. Now it's negative to positive, negative to positive. Okay. R, C, then this is O minus Mg plus X. And this R. Of course, this is R dash. Now, this on further hydrolysis in the presence of acid. The water molecule can be written as H plus OH minus. Now look at this. Minus 2 plus, minus 2 plus. So you'll get RCOH. This is R dash. And see, for convenience, let us take this as R double dash. Just to have some clarity. Okay. So this is how we get the alcohols. Let us take some examples. Now let me consider the R and R dash as hydrogen, R double dash as methyl. Now in this case, what do we get? See, the mechanism is going to be the same. Let me just give you the reactants and the product. See, the reactant is now formaldehyde or methanol. The Grignard reagent used is, of course, methyl magnesium. You can take bromide, iodide, whatever it is. Of course, iodide is better. Now, coming to this, we get, see, in all the cases, it is, of course, R and R dash hydrogen. Considering this, we get this. Okay. So, we can generalize it saying formaldehyde with the Grignard reagents. Let us take RMGX followed by water H plus. We get 1 degree alcohol. So formaldehyde gives a primary alcohol. Now take R as methyl, R dash, hydrogen, R double dash again is methyl. Okay. Now in this case, the carbonyl compound is going to be ethanol or acetaldehyde. Not just ethanol, whatever may be the alkyl group at this place, I mean aldehydes other than formaldehyde give 2-degree alcohols with Grignard reagent. Okay. Now if R, R dash, even R double dash, all are methyl groups. So this is a ketone. Propanone, you can say acetone, common name. So in this case, we get a tertiary alcohol. Okay. A 3-degree one. So in general, ketones with a Grignard reagent followed by hydrolysis in the presence of acid form 3-degree alcohols. Okay. Some more. See with acid halides and esters. Let us consider it this way. R C double bond O G. Now this GR, the group, if at all it is X, then that will become acid halide. If that is OR, or you can say OR dash, it becomes an ester. Now when this is treated with Grignard reagent, now it's again the same. Look at what happens in the first step. See, this happens in 2 steps. When first molecule of Grignard reagent is used, look at what has happened. Now the group goes off and we get a ketone. RC double bond OR dash. The thing that gets eliminated is MgX, then this G. Right? Now this carbonyl compound formed in the first step further reacts in the same manner as we have seen in the previous case. to form a tertiary alcohol. Now see the mechanism, the same. It will be like this. See, even in the first step also, we can give mechanism the same way as we have given in the second step, but it will be like, see, as and when this attacks, this bond goes towards oxygen, becomes negative. Now, as and when this comes back, this part goes off. Even that way also can be given, but I've given it in just one step. Okay. Now, coming to this, it's RCO minus Mg plus X, then R dash, another R dash. On hydrolysis, we get a tertiary alcohol. So every molecule of an acid halide or ester reacts with the two molecules of Grignard reagents, finally giving rise to 3-degree alcohols. So that is the interesting point here. Okay. In the previous case, it was just 1:1. But in this case, it's 1:2. One molecule reacts with two molecules, and finally, a 3-degree alcohol is formed. Let us take different cases. See if R is a hydrogen and R dash is methyl. In such a case, if we go for an acid halide, this is formyl chloride or methanoyl chloride is the IUPAC name, if we consider an acid halide. Or otherwise, if an ester is concerned, taken into consideration, this will become formate ester. Now, when these are treated with any of these, it's treated with the Grignard reagent. No doubt, in the first step, we get a carbonyl compound. And finally, see, in these cases, we get a 2-degree alcohol. A secondary alcohol is what we get. So, in general, formyl chloride or formate ester give 2-degree alcohols with Grignard reagent followed by hydrolysis. Okay. Now, if suppose both R and R dash are methyl groups, then it will be look at this. So this is ethanoyl chloride or acetyl chloride. If it is an ester, of course, it's an acetyl derivative of ester or ethanoyl derivative of ester. So when this is treated with the Grignard reagent, we get a tertiary alcohol. Not just acetyl derivatives, but any acid halide other than pharmyl. Or any ester other than formate ester give a 3-degree alcohol. Okay. So this is how alcohols can be prepared from Grignard reagents. Now, see from ethers, we can prepare alcohols by simple hydrolysis. Look at this. Dilute sulfuric acid, of course, adds water, will get two different alcohols in this case. Then from cyclic ethers or epoxides, or you can also say oxiranes. Okay. Now in this I have several varieties. The first one is acid catalyzed ring opening of epoxides. Okay. Let me take unsymmetrical epoxide so that I can give you some more clarity. Now look at this carbon which has got a methyl group surrounding, whereas this carbon has just got hydrogens. So we can say that this is a more hindered or crowded, more crowded. Now this one is less hindered or less crowded. Okay. On acid catalyzed hydration, as usual, H2O and H plus. See, we get a glycol. Nothing but 1,2-diol. Okay. Let us see the mechanism of this. Now, this is what we have considered. Now, this epoxide with the H3O plus. Look at this. Acting as a base. The lone pair is given to a proton. Now we get a protonated epoxide. Okay. Protonated one. Of course, a water molecule. Eliminate. Now within this, as we know, this is more hindered or more crowded. This one is a less hindered or less crowded. But see, when this is treated with water, now this attacks on the more hindered carbon atom. I mean, via a more stable carbocation. Okay. So here the attack is on the more stable carbocation, which actually gives rise to a more stable carbocation. More hindered carbon is being attacked. More crowded carbon is being attacked. Now look at this. CH3, C. Let me just show it from the other side, because here the attack is from the back side. Let me show it properly. Of course, it attacks the more hindered one or more crowded one, but the manner in which the attack occurs is anti-addition. So now we get this. Okay. So this is how we get the anti one. Now let us remove this proton